Okay, so let's do a couple of basic commands in Motion Genesis. I'm going to be copying and pasting so you don't have to watch me type. The first command is Newtonian frame, and what that's going to do is create a Newtonian reference frame along with the nx, ny, nz unit vectors and the origin point no. And it's opposed to a rigid frame, which I could do another reference frame, which is rigid frame C, and that's going to create a C0, a CO, which is an origin, and a CX, CY, CZ reference frame. And the only difference between these two, they're both reference frames, not rigid bodies, they're both reference frames, is that the Newtonian frame can't be, the origin can't be accelerating or in the reference frame can't be rotating. So you can't have any you can have a translation of the reference frame, but you can't have any acceleration. So it can be going pure translation, constant velocity, but no accelerations. So Newtonian reference frame, no accelerations. Rigid reference frames can spin around, can accelerate, etc., etc. And so that's the difference between Newtonian reference frame and rigid reference frame. And I can have multiple Newtonian reference frames. So I can have Newtonian reference frame N, I could have a Newtonian reference frame L, for example, and I can have multiple rigid frames. I can have rigid frame C, rigid frame A, etc., etc. Okay, so that's the difference between Newtonian reference frame and rigid frames. So the next command we're going to look at is constants. And so I can have a constant. In this case, I made a constant AX, and so that'll be a scalar, AX. I could also do more than one declaration at a time. So I can say, for example, do constant F1, F2, and I'm going to use here like an array. I can say B2 through B7. So B2, B3, B4, B5, B6, B7. So that's a nice way, a little shortcut of doing multiple constants in one declaration. Okay. All right, we'll get to variables in a later video, but there's constants and variables. We'll get to variables later. So the next one I'm going to do here is I'm going to say a vector, and so we've talked about this before. This is the symbol for vector, the little greater than symbol. So as A is a vector equals AX, and we've talked about this before. Motion Genesis is not case sensitive. It uses the case from which I first declared that variable, so it will keep using lowercase ax. I'm allowed to use uppercase ax. It will go ahead and convert that back to lowercase because it's not case sensitive, but Motion Genesis uses whatever case, lower or upper case, that originally declared it as. So N was declared as capital, so NX, NY, and Z are capital. C was declared as a capital C, so it used capital CX, CY, CZ. But I'm allowed to use lowercase n and lowercase c if I want. It just will revert back to the uppercase. In fact, I'll do that here. I'll change this to lowercase nx, and it will change back to an uppercase nx example. All right, so I'm going to do ax, and it's going to respond back to me what it thinks it is. So line 5 is my input. Line 6 says the vector A is lowercase ax plus uppercase nx vector. All right, so it took care of cases. I'm going to do a couple more vectors here so we can do some additions and things like that. So I'm going to do a vector B, which is B2 cy plus B3 cz. So I've already defined that the constants B2 and B3, I did that up here, my constants, and CX and CZ were declared through my reference frame C. So it's going to respond back to me. Again, it's going to change the case on me, which is no big deal. All right, so one more vector here. I'm going to do F equals F1, which was a scalar I defined earlier, and F2, again, the cases are different, with CX and CY. So it's going to go ahead and respond back to me in line 10. Again, it changed F1 lowercase into F2 lowercase, but again, not case sensitive. All right, so now I got three vectors in my workspace here. You notice that A is in the N basis, and B and F are in the C basis. So I can do some various things here. So let's do a simple addition, for example. So A plus B. Now, there's nothing special about the left-hand side. This is the name of my vector. I'm not very creative, so I called it A plus B, which equals the vector A plus the vector B. This is just a simple vector addition. So it's going to do just like we expected. And it's going to have mixed bases. It's going to do B2 CY plus B3 CZ plus AX NX, a mixed basis. No big deal. All right, so let's do another vector here, another vector addition. Sum. Now I'm going to do, of course, again, this left-hand side is anything. I could have called it junk or goobly gop or whatever I wanted to call it. So I said A plus B, which is the result I had before, which is fine, minus this vector F. So again, this is a case of vector subtraction, but it's basically a vector summation. And it gives us exactly like we thought. Now, it groups terms, so we have B2 minus F2 times CY, right? So it's collecting terms by the unit vector, basically. Okay, so another command, our next command, is going to be a simple statement. So 10 times b. Now above we've had what do we call declarations. B equals something, F equals something, A plus B equals something, sum equals. I'm declaring what A plus B is. I'm declaring what sum is. Here I'm not doing declaration. Here I'm just saying 10 plus B. And so what's going to give me back, it's going to say the result. The result of 10 times B, the result of 10 times B is 10 times B2 plus CY plus 10 times B3 times CZ. So you notice that line 15, line 15 was 10 times B, and it gave me a result, and then line 15 shows up again. And so what's going to happen in the end when I go to save this as an HTML file, this command, this request of just saying, tell me what 10 times B is not going to show up in that final summary, that result file. Okay, so let's do one more here. And I'm going to go ahead and do b.f. Again, the left-hand side, this is a scalar because it's a dot product, is just whatever. I'm just making a convenient name. We could have named it d or scalar or whatever the name is. It's just I'm just making it up for this example. You can call it whatever you want. And the right-hand side, of course, is the actual function dot b and f. Now I can dot b and f because b is in the C basis and f is in the C basis. If I try to dot b and a, for example, it's going to complain because it says, I don't know how they're related. I haven't told it what the rotation matrix is between C and n yet is. But right now I can only dot b and f because those are in the same basis. So it's going to do it just like we expected. And it's going to say b2 times f2 like we expected because we have a b2cy and f2cy. There's no c1, and of course there's no cz in common. Okay, one last command here, b cross f. Again, the left-hand side, I'm just making it up just to remind us that this is the b cross f. And it does b cross f. And again, it can do this because b and f are in the same basis. And it does the math. I think of Motion Genesis as a giant calculator. And it does the math for us just fine. And you can verify that offline if you want. Okay, now I want to finally save all this information. So I'm going to save it as junk. Again, I'm just naming this file because I'm going to throw it away later. But junk.html. And it's going to create a file with all my, in this case, 18 lines in there. It won't save this last 19th line because it doesn't save the save. That'd be like a recursive thing to save the save command. But it doesn't do that. And of course, line 15 isn't going to show up there. Line 15 is going to show up, but it's not going to be 10 times b. It's going to be b.f, and I'll show you that in a second here. So I'm going to go ahead and save this. It's to save the junk.html file. And I'll go up my browser now and open this. Okay, and here is the junk.html file. And again, it's got all 18 lines. Again, line 15 is that b.f. It didn't do this 10 times b because that was just a simple request. I didn't do any declaration. I was just saying, tell me what 10 times b is. It told me, moved on, kept the same line number. And of course, that line 19, the save command doesn't get saved either. Okay, and so that's the end of this second Motion Genesis tutorial.